Hello guys, hope you're doing well. And as always, if you're new to my channel, I would request you to subscribe to my channel so that you shall be able to watch all my latest engineering videos that I will upload on my channel for you guys. Thank you. Alright, the problem at our hand today is basically we need to determine the magnitude and direction theta of equilibrium force FAB exerted along the link AB by the tractive apparatus shown. Okay, so we need to calculate the magnitude of this FAB, which is making an angle theta with the x-axis. Okay, and this apparatus is basically being termed as a uh, tractive apparatus. Okay, and this apparatus is mostly used by athletes to strengthen their thighs, and most of the time also used by the patients for their rehabilitation. Okay, so this is we have understood that work that is being done by this tractive apparatus, and then if you look at it, it is being suspended by mass 10 kg. So this is the mass 10 kg, it is being suspended. One assumption that we will make over here is it is being suspended by what is called as a cable. Okay, and this cable is being running over on these pulleys, one pulley, two pulley, and three pulley. And from here, if we go to point A, and from here to go to this pulley till it is being attached with this weight of 10 kg, it is a single cable. So because it is single cable, this cable will be exerting the same force all over in this cable as a result of this 10 kg load. So the tension in this one single cable could easily be calculated by the weight 10 kg into 9.81, which means tension is nothing but m into g, and which is 98.1 newton. So along everywhere in the cable the tension will be 98.1 newton. Then we will have to draw the free body diagram, and we know our concurrent point or the pivot point will be this A. So this is the point A, and from here to here we can treat it as this 98.1 newton, because it will have the same tension here also, and from here to here it will also have the same tension, 98.1 newton. But this is not, here it is not the cable, but it is the link which is being attached to the feet, and then there is a pad which is basically being holding this feet. This tractive force is basically force FAB, which we have put it over here, making an angle theta. Okay, so now basically we know this is our pivot point A. We can resolve the three forces along the x and y axis and minus x and y axis. This force will have two components, one along the x and one along the negative y. This component will have two component, one along the negative x and one along the positive y. And this 98.1 newton force will have two components, one along the negative x and one along the negative y. Okay, so you can see these are the components that I have just told you. They are being added by head to tail rule method. Okay, so these are the respective components that we have just basically been discussed with you over here. Okay, so now we have to basically resolve the forces along the x and y axis. Okay, so when we resolve these forces along the x axis, we have the components as this component will be FAB cos theta, then this component will be uh, because the angle is 75 degrees, so it will be 98.1 cos 75, and since it is on the negative x-axis, it will be having minus sign. And then there is another component, which is this component. Its x component will be again 98.1 cos 45, but negative sign because it is acting along the negative x-axis. So if we simply, this equation is basically unknown into FAB and cos theta. We simplify this above equation, we get FAB cos theta equals to 94.1757 as equation 1. Now we sum forces about the y-axis. When we sum forces about the y-axis, One of the components will be this vertical component, which is this one, which is 98.17 sine 75 along the positive y. The other component will be 98.1 sine 45, which is this component, but it is acting along the negative y. It is acting along the negative y. So it is 98.1 sine 45 with a negative sign. Then this component, main force AB, the vertical component, which is this one, this component, if you look at it, its sense will be in the towards the negative y. So it will be FAB sine theta, negative sign here. So if we simplify this equation, we will get FAB sine theta equals to 25.390. Now we can see this equation 2 and this equation 1 have two unknowns, FAB and sine theta and cos theta. We can basically solve this 1 and 2 and divide 1 and 2 to get this equation, which is FAB sine theta upon FAB cos theta equals to 25.390 over 94.757. So FAB and FAB gets cancelled up. We know sine theta upon cos theta is nothing but tan theta, and we divide this ratio with this ratio, we get it as 0.27. Now we know theta equals to tan inverse of 0.27 will give us 15.11 degrees. Now we have got the theta, we can put this theta in equation 2, and which is basically, this is our equation 2. FAB sine theta equals 25.4, and we can make it as FAB sine of 15.11. In place of theta, we put the value of theta, and we get FAB equals to 97.40 Newton. Okay, so it was a good problem, and I hope this problem solution will help you. Thank you very much. You have a very good day. Bye.